Give me 1 second. Let me log in. Perfect. Let me look at here. Let me remove this real quick. And JavaScript, right? So the three things are JavaScript and React. JavaScript, TypeScript, and React. Yes. Okay. But yeah, can you guys not hear it? Oh, it's muted. Okay. Okay. But I don't, like, I have started, but I don't remember, exactly a lot of things. So I might need to brush up on that. But okay, this is added to my learning, right? No? Yeah. Okay. So let's continue with this.
All right, we're going to get to the decimal class in a second, but first I just want to show you a couple neat things you can do with the int class in Python. So if I pass in a number as a string, it will convert it. We're casting this string 100 to the integer 100. Now a cool trick with this class is that if I optionally pass as a second argument, I can pass a number. It will take this second argument as the base that the number should be converted from. So 100 in base 2 is 4 in base 10. And this first argument has to be a string. If I try to do 102 like that, it throws an error. So why is that? This is because when you're converting from one base to base 10, you might have things in the string that aren't numbers. So 1AB is perfectly valid in base 16, and that's apparently 427. But obviously, 1AB is not an integer. So we have to have a string as the first argument if we want to convert it from a different base. And so this int class is very cool and handy. And let's look at another totally different number class in Python that solves some of the problems we saw with floats in the last video. Remember, while floats are great at what they do, they have what's called a floating point error. And we saw this with 1.2 minus 1.0, we get something that's definitely not 0.2. And for some applications, these floating point errors can be annoying or even create unacceptable risks, like when you're working with money. And in these cases, Python has the decimal module. To use the decimal module, we're going to import a class and a function at the top of our notebook. And it's traditional to keep all imports at the top of your code. So from decimal, import decimal and get context. import. All right. So Python has some modules, basically handy pieces of code, available by default with your Python installation. So some of these things are available without needing to explicitly import them like we're doing here, like print or float. But some of these things, like the decimal module, require you to write an import statement at the top. So this says, from the decimal module, we're going to import this class decimal and this function getContext. So if we call this function getContext, we can use it now, it returns a context object with a bunch of attributes in it. And these are basically the global settings that get applied to your usage of the decimal class. We can change any of these settings we want just by saying getContext.precision is equal to 4. Now if we call getContext again, you can see that it's changed to 4. You can instantiate a decimal class with a number value. So if I do decimal 1 over decimal 3, it returns 0.3333 to 4 places of precision. And if we change the precision to 2, let's just do that, and then rerun this, you can see that we get it to 2 decimal places. Now, if I pass a float to a decimal, 3.14, don't be alarmed. This isn't a failing of the decimal module. We're trying to exactly replicate the float that was passed in, capturing all the digits of information. So this is actually a really good example of why floating point errors arise. It's taking this float and it's saying, this is what this float exactly is. What we can do in this situation is do decimal 3.14 as a string, and that looks a bit better. So there are actually many ways of representing numbers to the decimal class, and I encourage you to check out the documentation if you're interested in using it for your own project. So should you use a decimal class instead of floats when dealing with decimals? Not necessarily. Always round appropriately before showing values to end users. Be wary of situations where you're dealing with very small numbers or very, very large numbers. However, most of the time, I'd say 98% of the time, floats are actually just fine. So instead of sending back 1.2 minus 1.0, we can round it and then return that to your users. We looked at Booleans earlier, and you might have been left with the impression that there's not a lot left to say about them. True and false, right? How hard could it be? Well, there are a few actually tricky aspects of them that we need to cover. And because I'll use them day in and day out as a programmer, it's extremely important to cover these. Honestly, I occasionally find myself bringing up a Python terminal to double check a line of Boolean logic or confirm exactly how Python handles one case or another. So let's go to the code. The first thing I want to talk about is casting. So Python will cast integers to Booleans pretty nicely. 1 is true, and of course, 0 is false. In fact, anything except a 0 will be cast to a Boolean true. So something like -1 might feel false to us, but be careful. To Python, it's true. Even something like, let's do imaginary 1. That's true. However, imaginary 0 or float 0 are both false. So 0.0, and if we do 0j, they're false. Okay, so what about strings? Boolean true is true. Fair enough. Boolean false is true. That's because anything other than an empty string is actually going to be true. There's nothing special about this string false. It's just a string. Python assumes that it's true. Of course, an empty string is the only false string. But be careful, even putting something like a space in here, make sure that it's truly an empty string. What about data structures? We can cast these to Booleans as well. An empty list is false. An empty dictionary is false. If I put anything inside of here, though, it's true. Remember that none value that Python returns from functions that if you don't add any explicit return value there? Well, unsurprisingly, these get cast to false. Now, why is it so important to learn the rules of casting booleans in Python? Well, remember that booleans aren't usually used directly. You're usually checking the boolean value of statements inside an if statement or a for loop. So you'll very often use them in situations like this. My list equals 1, 2, if my list print my list has some values in it. Great. And what we're doing here is casting the value of my list to Boolean in order to evaluate. This is equivalent to writing this. You can also do something like this. A equals 5, B is equal to 5, if A minus B, print A and B are not equal. Great, didn't print. The only way that A minus B evaluates to 0 or false is if A is equal to B. Of course, this is a little overly clever. If we really want to do this, we could just do that. And that brings me to my next point. There is usually more than one way to evaluate a Boolean. So you have to be a little bit careful about keeping track of this logic. So let's look at a situation where we're evaluating, say, whether or not to go for a walk. So weather is nice is false. Have umbrella is true. So if weather is nice or we have an umbrella, we can go for a walk. If not, weather is nice or have an umbrella, we must stay inside. So if not, have umbrella, umbrella, or weather is nice, print stay inside. Else, print go for a walk. So if we have an umbrella, this tells us we can go for a walk. Looks good, right? But Python evaluates Booleans left to right. So this is saying not have an umbrella, which is false, or weather is nice, which is also false. So this whole thing evaluates to false. There are actually imaginary parentheses around the not have an umbrella here. So this isn't quite the logic we want. If we flipped the Booleans so that we don't have an umbrella, but the weather is nice, you can see that it does the wrong thing. It's telling us to stay inside even though the weather is nice. So there are a couple ways to fix this, and fix this in a way that would give us the correct logic. So first, we could do this. We could put parentheses around the thing that we want to evaluate first, and this would give us the correct logic. There's also kind of a cool thing we could do, which is rewrite this with an AND statement. So let me just copy this. If not have an umbrella, and not weather is nice. Let's do that. And this is actually the exact same logic we had before. These two are equivalent. Although it's not strictly necessary, it might be nice to put parentheses around this just for readability, like so. But that's just readability for humans, not computers. And of course, we could also flip the order of these statements entirely, which is probably the best and most readable way, in my opinion. So, if have umbrella, or weather is nice, print go for a walk, else print stay inside. So yes, Booleans are, at a certain level, very simple. However, it's critically important that when you're writing a Boolean statement, you be very careful. Think about how Python is evaluating each piece of the statement, and always double check your logic. All right, this is an exciting one. In Python, we're working with strings a lot, whether it's parsing them to extract some data or constructing them to provide some information to an end user. And Python has a lot of tools to both analyze and construct strings. And the first one I want to take a look at is called slicing. It's called slicing because we're literally taking a slice out of a string and returning it. So let's make a string. My name is Ryan Mitchell. Okay, and let's say we want to get just the first character of that string. We can do name 0. Remember, programmers always start counting from 0, so we say that m is at index 0 in the string. And we could also get the second character, name 1, which is that y at index 1 in the string. Well, what if we want to get the first 7 characters of a string, the words my name? We could use a colon, 0:7, which means get me the characters between 0 and index 7. Note that it doesn't actually get the character at index 7, which is the space after name. It gets the characters up to index 7. And there's also this sort of shorthand you can use with the slicing syntax, which is name 7. If you want to write a 0 here, you can just leave that 0 out, and it's equivalent to writing the 0. Similarly, if you want to get all the characters from index 11 to the end of the string, you can just do 11 and then leave that out. And this is really handy because we may not know the length of the string, so you don't actually have to write it in if you don't know it. It just goes up to the end of the string. So if you leave it out at the beginning, it starts at the beginning of the string. If you leave it out at the end, it goes up to the end of the string. It's also important to note that this slicing syntax is exactly the same when you're working with lists. So if I have a list, 1, 2, 3, 4, 5, I can take a slice of that list. My list, 2 to 4. Lists and strings actually have a lot of similarities in Python. So I can take the length of a string. So the string has 24 characters. I can also take the length of my list. My list has 5 elements. We're going to be looking at some other neat features of the slicing syntax later on when we look at lists. And so keep in mind that all these features can be used in the exact same way with strings too. So let's look at a few things now that are particular to strings. So Python is great at string formatting. There are a few ways to create strings in Python, including one very basic obvious way with string concatenation. So let's do my number is string 5. So my number is 5. We can do this with something called an F string. Simply type an F, which stands for format, then type your string without any spaces between this F and your string. So put your variables inside curly braces. My number is 5. Same exact thing. You can also write expressions inside the curly braces. So F, my number is, let's say 2, let's do 5, and twice that is 2 times 5. Whoops. There we go. You can even do rounding and number formatting. If we import the Python math library by convention at the top of the file, we have access to math.py, which is pi out to 15 decimal places. And we can display pi rounded to 2 decimal places with a colon and a 0.2f. So let's just write this. Pi is math.py. That's going to be pi to 15 decimal places. And then using the special string formatting syntax, we're going to round it to 2 decimal places. So f-strings came out with Python 3.6. It's a relatively new feature. Prior to version 3.6, the string format function was used, which is very similar. You can see the format function. I prefer f-strings now, but let's just take a look at it. Pi is .format math.py. And finally, a new way to write strings, the multi-line string. If you use 3 quotes, Python will go into multi-line string mode. If I were to put a new line in the string up here, it would return a syntax error. Yep, no good. However, sometimes you want to include new lines in your strings. So my string Here is a long block of text. I can add new lines. The text doesn't stop until it sees. Oh, look at that. What if I want to put literal triple quotes in there? I can use that backspace character to escape it. And if we print out my string, there we go. You see that this actually includes these backslash n's in here. This backslash n's are new lines. This indicates that we're going to a new line of text. And this is just what Python prints out when you're actually looking at the string. If I do print my string, you can see it renders it a little more nicely. So Python is fantastic. Python prints out when you're actually looking at the string. If I do print my string, you can see it renders it a little more nicely.
Let me note this format, multi-line threading. So here is a block of text, right? And then once you write that, you have to say, right, I can add a new line. Once you write that, I can prove it like the idea here. So you use 3 quotation for that. And if you want to see that in right format, you do print my string. Okay, nice, good.
If I were to put a new line in the string up here, it would return a syntax error. Yep, no good. However, sometimes you want to include new lines in your strings. So my string, here is a long block of text. If I want to put literal to escape it, and go. You see that this actually includes these backslash n's in here. This backslash n's are new lines. This indicates that we're going to a new line of text. And this is just what Python prints out when you're actually looking at the string. If I do print my string, you can see it renders it a little more nicely. So Python is fantastically flexible at manipulating, parsing, and creating strings. There are hundreds of string functions and ways to use them. We'll be covering more ways to use them, but if you want to look for more information in the meantime, I suggest checking out the official documentation on Python's website. So here's one we haven't covered yet, the Python byte object. So in day-to-day programming, you won't often be working with it. It's common behind the scenes. It's data that gets passed around in a program, but it's rarely manipulated or modified directly. As we all know, computers store information as ones and zeros on the disk. When Python loads that data, there's information that tells Python what the type is. If it's a string, an int, some sort of class with properties, etc. In some cases, though, all you really want is data, some random series of ones and zeros. And so there's the bytes object. What kind of data is the bytes object? Who cares? What type is it? Well, it's a bytes object. It's a sequence of data, and that's all Python needs to know. The bytes object is commonly used for streaming files or transmitting text without knowing what the encoding is. You'll see it pop up a lot in Python libraries. So let's take a look at how to recognize and use this bytes object. So first, let's create one. Now this looks like we're casting the integer 4 to a bytes object, but not so fast.
Hold on, let me do something real quick.
What this does is it actually creates an empty bytes object that's 4 bytes long. Each byte here is represented with a \x followed by 2 hexadecimal or base 16 numbers. So remember that 2 hexadecimal numbers is 256 possibilities, which is the same as 2 to the power of 8 or 8 bits. And of course there are 8 bits to byte. Okay, so this is 4 bytes long. And this B here is used to differentiate bytes from a regular string. So if you see something printed out and it has the B in front of it, it's a bytes object. Let's make a bytes object with actual data in it. So to do this, let's do a fun emoji here. The eye roll. Okay. We need to tell Python what the type is. So we're going to do UTF-8. So in order to create the bytes object, you need to tell it what the type is of the thing that you're trying to encode so it knows how to find and isolate the data. And in this case, emojis are encoded with UTF-8, which is a type of Unicode transformation format. So once it knows the format of the thing you're feeding it, it can represent the data correctly. Let's call this smiley bytes. Okay, and there's the bytes for that emoji. Now, how do we go the other way, take a bytes object and represent it as a string again? For this, you need the decode function. And again, you need to pass the format in. So decode UTF-8. And there we go. Bytes objects are immutable, like tuples. So if we want bytes data that we can modify, we can use something called a byte array. Let's actually just take this, change it to a byte array. The syntax is very similar. We can see this is a byte array now. We can treat this smiley bytes object a lot like a string, including modifying a specific byte value using the string slice notation. So let's take this value at the last position. This is hexadecimal 84. And we can take this, and that's at index 3 there. So we're going to say it's 85. Let's see what that is. So how do we get hexadecimal 85? We can use the int library. Remember that? So let's take 85 in base 16, and then we set that. And then we want to decode it, see what we get. Decode UTF-8. It looks like a shrugging emoji. So that's how to find, detect, use, and modify bytes. Previously, we saw how the int class in Python could be used to convert any hexadecimal number into a decimal number. But let's say you're stranded on a deserted island and don't have access to the int class. Well, okay, it's just good practice to do these things yourself once in a while so that you know how they work. So, without using the int class or any other Python conversion tools, can you write a function that takes in a string hexadecimal number and converts it to an integer decimal? Here are a few things to make it easier. I provided you with a handy dictionary you can use. So the string 0 is the integer 0, all the way up through the string f in hexadecimal is the decimal integer 15. In this challenge, don't worry about hexadecimal strings greater than 3 characters long. If you want to build a more general purpose function that can handle larger strings, go for it. But if you look at these test cases, I'm only looking for 3-character strings. As with the previous challenge, make sure that you're checking your inputs. So this string, zztop, should return none. And this one has a G in there, so that's not in our dictionary either. As always, if you're stuck or just want to get some ideas, check out the hints file.
Okay. In Java, this will be a hash map. Okay, let me take a note of this. Dictionary is equal to hash map in Python. What does our dictionary say? 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 15. Integer decimal. Okay, so if it is valid, if it is not valid, it's like a simple if statement. So what's the string, right? So the function is called hex to dec. Then it gives 0. Let's say it gives 0 in my case, right? Then I'll call so what I got is a string. Um, Hold on. What is this? 3.6, right? Okay, so if you look here, it's called def hex 2. This is the definition of the function. Def. I still don't know what pass is doing here, but yeah, hex to deck. Oh, give me a sec. Hex num. Okay, if this is the function, then it's a simple one. We will um so um in Java we use get function to get whatever is in the hash map. Here we have a dictionary. So how do I access something from a dictionary? Is like a contain function in a dictionary, or can I treat dictionary just like an array? Mm, again, let's not do. So let's open it like an array. I think I can do that. I think I can open it up like an array. So um, Just 1 second. There's something that fell on my iPad. I have to just clear that out. Okay, I'm good. So we have to check this, right? If hexadecimal is not valid, um, so let's say we open it like an array, right? For um, so let's say, right? Um, len is equals to len. Or is it hex num? Maybe not call it. Let's call it size, right? Good name. Nothing to worry about. Then for that, num less than, or do I have to write less than size? Wait, is that an issue? Can I not do that? Hold on. Mm-hmm. Wait, then what is it? So what should I use? In range size. Then hold on. There was structures. I mean, I did it on my. I guess I did it on my other account, which is my university account. Um, let's watch this real quick then.
Dictionary comprehensions are used to generate dictionaries from iterable structures. Just like list comprehensions create a new list, a dictionary comprehension creates a new dictionary. I'll show you a basic example. So here we have a list of tuples that we'll be using as our key value pairs. Remember, tuples work just like lists, except that you can't alter the value of tuples once they've been declared. And we can create a dictionary from this list of tuples like this. Animals equals item 0, colon, item 1 for item in animal list. And there we see our dictionary. There's this familiar for item in list statement, exactly the same in both list and dictionary comprehensions. But now we need to define both the key and the value separated by a colon instead of just a single value like we did for the list comprehension. And of course, this dictionary comprehension is surrounded with the curly braces, just like the list comprehension was surrounded by the square brackets. Now there's a more elegant way to write this dictionary comprehension as well. Let's check that out. So we can actually say key is equal to value for key comma value in animal list. So what kind of sorcery is happening here? Well, whatever is between the for and the in this statement is what each tuple of animal list is getting assigned to. So remember when we saw earlier when we were discussing tuples and sets, Python allows you to unpack values into multiple variables as long as the number of variables you're assigning the values to matches the elements in this data structure. So we have 2 items in each tuple here, and we're unpacking them into 2 key value variables here that we can use. And this just makes it a little bit cleaner. So we can do something like this, but if we try to unpack it into other item, you can see we'd get not enough values to unpack, expected 3, but actually got 2 when we iterated through this list. So that's the dictionary comprehension. Pretty straightforward. Well, what if we want to take our animal dictionary and turn it back into a list? Let's look at the dictionary function called items. Remember we have animals.keys and animals.values. There's actually animals.items. And items returns a dict items object containing a list of key value pairs. So we can turn it back into something that looks like this animal list that we started with just by doing list animals.items. And there you go. But let's say we wanted to get a...
Okay. So we will use hex numbers dot keys. Come in this loop and this loop will pick the first element, right? So if num starts from 0, right? So if hex hex num at num not in. So what if I say not in hex dot keys? Oh, it works. Okay. Let me take a quick note of that. So okay, not in is equal to like contain, and yeah, for now let's just leave it to that. So okay, hex dot keys, if it is not, then return none. Otherwise, so if you look, I'm opening from the how do you take power of something? How do you take power? Math dot power, power. So hold on, if I remember, this is the first one, right? Okay, yeah. Put this down. Import math. That's how you take power. I don't know. Math dot power of 16, comma. Oh, if I do double multiplication, does it mean taking power of it? Hold on. Oh, it does. So I could have just said that. But okay. Size minus num, right? Whatever you get here, so this is a return statement, right? Whatever you get here, okay, this and, if it does exist, right? If there is a key, so if there is such a key, Then I need to this needs battery. So what I do need here is okay. So if it is in, right, then okay, if I can I do that? Hex numbers dot oh, get is here as well. Get keys, pop item, values. Okay. Get um num. Okay, so hex number, no, no, hex num, num. Okay, whatever you get here, store it as uh, so converted value to 0, right? So whatever converted value is, right, add it to itself. What will that do is that, let's say the value was 1a, right? Come here, 1 will be 1, so 1 is found. 0 plus this whole statement will return 1. 0 plus 1, 1. So 1 is added. Again comes here with a. A is 11. So maybe, sorry, this needs to happen. So comes here, sorry about that. Um, so this value will come here, math dot pow, that will become minus. Um, give me 1 second. Um, okay, let's do it from the beginning, right? If the value is given 1a, the first thing that will open here will be 1. 1 will be found, 1, then 1 into size will be 0. Sorry, size will be what? 1. Num will be 0. 1, 16. 16 to the power 1 is 16. So, how do you comment out in Python? Is it not two slashes? No. Maybe hash. There you go. Hello world. So this should return 1 into 16 will be 16. Then yeah. What's the issue here? Oh, because I'm trying to write it here. No, come outside. Uh, oh, I have to run this first because it's saying it doesn't identify this. Okay, so not in didn't work, but then how do I check the key values? A should be there, right? There is the value A. No, let's place a breakpoint. So maybe I should stop it right here then. Can it not debug this? The argument of type function builder is not an iterable. Oh, okay. So I had to use this to get all keys. You have to use dot keys and then the open bracket and close bracket. But the algorithm is not correct because it's giving 160. I don't know why, but I cannot debug this for some reason. Strange. So this gives you what? Oh, actually, this gives you A, right? So if it is A, right, this gives you 10, and I'm doing 10 into 16, right? Let's say this is 1A, right? So see, it gives 416. You know what? You will get. So if it was A, right, you would get 16 here. Sorry, 11. Or 10. And 10 into 16. Oh, wait. The size will be 0 as well, right? Hold on. Hmm, can you do it? Not sure. Not sure. Oh, okay. So I cannot debug this, but I can debug the call. Oh, I'm so stupid. I'm not debugging the call. I was trying to debug the. Let's place a breakpointer here. Stop debugging and debug cell again. Okay. Convert is 0. Num is 0, but size is 1. Convert value is 160. 16 I get from here because num is 0. Then it hits in range. Okay. Oh, so this doesn't work if num is 1. If num is 2. So let's see if I try to debug this cell. Right, 1b, debug cell. In theory, I should get. Let's modify a bit. If size is equal to 1, then what you need to do is but do not do this part. Else do that. Wait, why did the. Oh, And here, and for now, um, let's call it value, right? You get the value now. Now comes the conversion part, for which I have to can make no import maths. This is enough, like no use where you so once you come in the value, you get the whatever the value in the string is. So the value will be, let's say for the first case, 10, right? Once you get the value, you need to find the place. But let's say there are two values. I'm starting from 0 will be here. But the power will be denoted here. This will be 0, this will be 1. So Yeah, I'm trying to build one algorithm. Like there are ways to tackle that situation, like okay, if the value is 0, then the size is 1, then do not do anything. If the size is not 1, so let me show you what I'm trying to do here. Okay. So, well, run it. But yeah, so this algorithm is correct. Like it runs one, the size was 1, then it handled it. But when the size is 2, like it will also work for this case, 0. But if the size is 2, then 1 and b. So 1 and b, size becomes 2, comes there. For 1, it should be 1. The conversion only needs to happen if it is more than 10. But yeah, this is not a very good looking, you know. This is like just completely throwing bricks at the wall. Hold on. If we are gonna use it so many times, let's get it value for it. Just use value there, value there. So if value is more than 10, more than or equal to 10, then run this. Otherwise, so 1 comes, no need to look for anything. But I don't get, I'm still kind of still trying to find why it doesn't debug, you know. There's no option to debug. Yeah, and there's also like it doesn't case check for more than three, so I don't need to do it for six different values. I can just write it for the value, but this would be a good, you know, practice. One B comes here. Value dot. So what does value become now? Value is one. So that becomes one. Value is 11. Then it becomes 11. It's still 2, 1. So 11 into 16 should be what? Wait, then why is it? Oh, it's B, sorry. B is 11, right? Twenty-six. Mm, okay, it is 27. Interesting. 16 plus 10 will be 26. Wait, so what was the algorithm that was written? 10? Oh, okay. I can see where it's going wrong. 1 will be 16, and A is at 0th place. So that means instead of doing all of this, what I could have done is simply subtract 1 from it. That's crazy. Now I do not need to check this case. I do not need to write this. All I need to do, hold on, Control Z. So this becomes what, 0? Let's let's run it again, okay? How do you end this? Executing, right? Stop cell, okay. Debug cell. But where did it go? Yeah, this is what I'm talking about. Like it runs for once and then it stops. No variable. And no. Oh. But I forgot that every time you make an update to that, you have to update this. Value will be 10. So comes here. Leaves as 10. And wait. Okay. Yeah. So this needs to change. Debug cell. Comes here, comes here. Boom, boom. 10. Returns 10. Comes here, returns 10. Perfect. This will return 0, 0. What will you return? 12. Comes here. Size is 2. Value is 1. Has to be that then. I don't think it will still affect the 10th and the 0th place. So initially my algorithm was right because I was thinking like, so okay, there's a very, what do you call it, difference in Java, like length here. Well, actually never mind. That was my bad. I was counting wrong there. What did you return? 27, right? Yep. 960, there you go. Perfect. Done. Wait, I just watched these videos. Why it's not recognizing that?
row. For example, the string AAAAA, BBBB, AAA. All right, I hope the hex didn't vex you too much. I have two solutions that I want to go over with you. The first is pretty straightforward. Here, I'm assuming that everything sent into this function is a string, or specifically a list of characters. The only test cases I gave you were strings, so if you did check for integers or some really tricky input, you're a far more diligent programmer than I am. Good work. But here, I was only worried about strings. And just as an upfront check, I'm going to go through every character in hexnum and just make sure that it's something I can process, that it's something in this dictionary that's provided. After that, I know we're good. There are three cases: 3-character strings, 2-character strings, and 1-character strings. For the 3-character strings, I take the leftmost character, multiply it by 256, or 16 squared. Remember, this is the 256th place in a hexadecimal number. Then I take the middle number, multiply it by 16 because it's in the 16th place. Then I have the ones place. I just add that on. I have a similar approach for the next two cases, and then you get the answer. Okay, so let's look at another solution that can handle hexadecimal strings of any length. Just run through these real quick. We're looking good so far. So here I have the exact same checking code to make sure that every character passed in is in the dictionary. Then we iterate through the characters backwards by using the string slice with the -1. So we're starting with the rightmost character, the smallest one, and then in each loop, we take that number and multiply it by 16 to this exponent here. And so you see the exponent starts at 0, and we add 1 to it every time we loop through after we do the multiplication. So the first time we loop through, that exponent is going to be 0. And 16 to the 0th power is 1. So if you remember way back from math class, anything to the 0th power is 1. So we're taking the hex value of that rightmost character, multiplying it by 1, then adding it to our decimal value, which we're keeping track of as we go through as well. The next time we go through, our exponent is going to be 1, multiply it by 16, then multiply it by 16 squared, or 256. Then we keep looping through, multiplying it by bigger and bigger numbers, bigger and bigger powers of 16, until we are completely out of characters, -1. The exact same. Let's look at another solution that can handle hexadecimal strings of any length. Just run through these real quick. We're looking good so far. So here I have the exact same checking code to make sure that every character passed in is in the dictionary. Then we iterate through the characters backwards by using the string slice with the -1. So we're starting with the rightmost character, the smallest one, and then in each loop, we take that number and multiply it by 16 to the rightmost character. So we're starting with the rightmost character, the smallest one, and then in each loop, we take that number and multiply it by 16 to this exponent here. And so you see the exponent starts at 0, and we add 1 to it every time we loop through after we do the multiplication. So the first time we loop through, that exponent is going to be 0. And 16 to the 0th power is 1. So if you remember way back from math class, anything to the 0th power is 1. So we're taking the hex value of that rightmost character, multiplying it by 1, then adding it to our decimal value, which we're keeping track of as we go through as well. The next time we go through, our exponent is going to be 1, multiply it by 16, then multiply it by 16 squared, or 256. Then we keep looping through, multiplying it by bigger and bigger numbers, bigger and bigger powers of 16, until we are completely out of character.
Okay. I need to check something real quick, then I have to go use washroom. One thing that I noticed that I didn't increase num anywhere and it did it automatically. So what if I do increase num by 1? Does that mean it will increase it by 2 every time? Let's see. Huh. So if you don't increase num, it will increase it automatically. And if you do increase one, it will wait for you. Okay, perfect. I'm gonna go use washroom real quick. And then once I come back, we'll resume where we left off. Okay, let's continue, shall we?
Characters. If we go down here, you see that handles much bigger hexadecimal numbers. If you ever run into a programming problem where you're not sure how to do it at first, try narrowing the scope. So, how do you do it for one character, for two characters, for three characters? Try to find a pattern, get a feel for it, and then you can approach the general case.
Let's give the chapter quiz. Let's see. Oh. Wait, this will change the base value, right? Wait, what?
We've looked at strings in some detail already. All right, we're going to get to convert it. We're casting this string 100 to the integer 100. Now, a cool trick with this class is that if I optionally pass as a second argument, I can pass a number. It will take this second argument as the base that the number should be converted from. So 100 in base 2 is 4 in base 10. And this first argument has to be a string. If I try to do 102 like that, it throws an error. So why is that? This is because when you're converting from one base to base 10, you might have things in the string that aren't numbers. So 1AB is perfectly valid in base 16, and that's apparently 427. But this is 4 in base 10. And this first started from, so 100 in base 2 is 4 in base 10. 100 to the integer 1.
Hold on. Yeah, I want to take notes of this, but thing is, for some reason, I don't know why, yet my table is not very. Never thought I would have to do this. Okay, let's run it then. I want to take quick notes. And
100. Now, a cool trick with this class is that if I optionally pass, as a second argument, I can pass a number. It will take this second argument as the base that the number should be converted from. So 100 in base 2 is 4 in base 10. And this first
oh,
argument has to be a string. If I try to do 100,
so the question is, what is 101 in from base 2 to base 10? 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2. Oh, you cannot see what I'm writing. Sorry. Now let me share what notes I'm trying to make here. So plus 2 plus 0 plus 2 raised to the power of 2 will be 4. This will be 6. I don't think 6 is in the option there. Oh, sorry. Well, silly mistakes. This should be. Yep. Five. And let me take a quick note of it. Base to be converted from number that should be converted. Perfect. So this will be 5. I think it rounds down, or does it rounds up? I think it rounds down. Yep. So let's take just chapter quizzes are the points that you should note from this section. Will be 8 and also rounds down. Okay. 0 is false. Everything else is true. This should be true. Yep. So let's put it like this so that in future we remember. 0 is false. And I believe this is true in any language. I don't really need to make a note of it, but just in case. Okay. Which class might be used to store precise amount of bang which class should be used? So the question is either it's going to be decimal or float. Sorry, decimal is 10 place, right? Binary, yeah. Uh, int is integer, so float base 16 is hex. Float, float. I knew this that float will cause that error, but
All
float.
right, we're going to get to the decimal class in a second, but first I just want to show you a couple neat things you can do with the int class in Python. So if I pass in a number as a string, it will convert it. We're casting this string 100 to the integer 100. Now, a cool trick with this class is that if I optionally pass as a second argument, I can pass a number. It will take this second argument as the base that the number should be converted from. So 100 in base 2 is 4 in base 10. And this first argument has to be a string. If I try to do 102 like that, it throws an error. So why is that? This is because when you're converting from one base to base 10, you might have things in the string that aren't numbers. So 1AB is perfectly valid in base 16, and that's apparently 427. But
Uh,
obviously, all right, we're going to get to the decimal class in a second, but first I just want to show you a couple cool tricks. Now, a cool trick with this class is that if I optionally pass, do 127, but obviously, let's look at another totally different number class in Python that solves some of the problems we saw with floats in the last video. Remember, while floats are great at what they do, they have what's called a floating point error. And we saw this with 1.2 minus 1.0, we get something that's definitely can create unacceptable risks of our notebook. And it's traditional to keep all imports at the top of your code. Python has some modules, basically here, text. So precision text object with a bunch of function get context. So if we call this function get context, we can use it now. And these are basically the global settings that get applied to your usage of the decimal class. We can change any of these settings we want. A bunch of attributes and require you to write an import statement pieces of code, and it's traditional to annoying or even create unacceptable risks, like when you're working with money. And in these cases, Python has the decimal module.
uh, I thought decimal was something else, like base 10, base 16 in that fashion. Creates 4-byte objects. Okay. T empty object. Sorry. There's three. Ah, what will happen if I retake quiz? Oh, it'll be the same questions just asked again. Oh,
We looked at strings in some detail
sorry.
already. In Python, strings and lists are very similar types. The slicing syntax used for strings is also applicable to lists. So if we have a list 1, 2, 3, 4, 5, my list 3 to the end, there we go. So this is the slicing syntax. Another cool feature of the slicing syntax is that you can use a third value in here. So normally you'd use two values, the start and then the end, but you can also pass in a third value. So if we do my list 0, 6, let's just go from the start to the end with a step size of 2, that'll print out every other item. Of course we can put in a step size of 3, that just gives us those two items. And of course all of this is equivalent to colon colon 2, because if you're going from the very beginning to the very end of the list, you actually don't have to give any values. It's assumed that you want the beginning and the end.
Okay. So list slicing and so in theory I didn't have to call to get the length. I could have just done this. This will give me 1, 3, and 5. 3. This will give me 3. Sorry, 1 and 4. 2. Okay, so always the first, sorry, you cannot see what I'm doing, element, then gap of two, excluding first element but including last.
And it might be easier to play around with this feature if we can somehow dynamically generate much longer lists than just typing this all out by hand. And for this, we can use the range function. The range function is a new sequence type we haven't covered yet. It's a bit like a tuple. It has an order and is immutable and isn't frequently used except for looping through it in code like this. For I in range 100, whoops, print I. Okay, and this is kind of an annoying output, so I'm just going to go ahead and clear that cell. But you can also take the range and convert it to a list. So my list equals list range 100. So we're converting or casting it to a list. And now if we take this and go through every other number, there we go. We can also do a step size of 5, all right, or 10. What happens if we enter a negative number? We actually step through the list backwards. So a negative step is stepping backwards through the list. We can even do negative 10. That's pretty nifty. So all of the things we've been doing so far have been about reading data from lists, taking slices, extracting one value at a time. Let's look at how to actually modify the lists. So let's grab this. Let's actually just do 1, 2, 3, 4. My list dot append 5 and then print my list. Great. Append adds an item onto the end of the list. If you want to insert an item at any position, you can use insert. My list.insert position 3, so that's the index, any value, and then print my list. There you go. There are a couple ways to remove items from a list. The first one is called, conveniently enough, remove. My list.remove, and you don't have to pass an index in here, just the value. And then if we look at my list again, you can see that's removed. But be careful, if the item isn't in the list and you try to remove it, it'll throw an error. So if we run this a second time, we can see that we get the error. The second way to remove an item from the list is with pop. MyList.pop. You don't have to pass an argument at all. It just pops an item off the end of the list. And it also returns it to you. So now if we look at my list, there we go. We just have 4 items in it. We could also do something like this. While length of my list, so while there are items in my list, remember this will evaluate to false when the length of my list is 0. Print mylist.pop. And if we look at my list now, it's empty. Remember that example earlier about how computers write values in memory? Let's try this out. A is 1, 2, 3, 4, 5. B is A dot append 6, and let's print B. We can see that modifying A also modifies B, which we've set A to. But we can use a Python trick here called the copy function, and this makes an identical copy of the list stored separately in memory. So let's take this whole thing. Instead of setting B directly to A, we're going to set B equal to A dot copy. And let's just print out both of them so you can see them side by side. And so you can see the difference between setting a variable to another variable and making a copy of it, setting it to the value of that variable. Lists are one of the most fundamental and useful data structures in Python, and it's important to get a feel for how they work. So I encourage you to play around with them in this notebook and get ready for some more fun with them as we progress. All right, let's take a deeper dive into two data structures we've covered only briefly before. We're talking about tuples and sets. But first, let's talk about sets. Remember, a set is declared using curly brackets, like so. A, B, C. My set. There we go, it has those curly brackets. You can also define it by passing any sort of iterable object in the constructor of the set class. So my set, and here we have a set object constructor, and then you can do A, B, C. Same exact thing. Or you could even use a tuple in here. So here we're passing a tuple with A, B, and C in there, and we still get the same set. One common pattern in programming is to remove duplicates from a list. Well, because you can convert a list to a set and then back again, and sets can only contain unique values, this becomes pretty easy. So let's make a list that has some duplicate values in it. B, C, C, or let's make that a C, it doesn't really matter. My list is equal to list set my list. And there we go, we've deduplicated my list. And this highlights another important property of sets. The order doesn't be C that has some duplicate values in it. B, C, C, or let's make that a C, it doesn't really matter. My list is equal to list set my list. And there we go, we've deduplicated my list. And this highlights another important property of sets. The order doesn't matter. So sets aren't ordered lists. They're more like big bags of elements all jumbled up. So keep that in mind when you use, and there we go, we've elements all jumbled up. So keep that in mind when you use this trick to deduplicate.
So I'm just taking notes right now. Declared with that, all elements are unique. And thirdly, the order doesn't matter.
Lists because sets are randomized. The order of elements in your list may not be the same coming back out. So because of this, you can't fetch elements by their index like you can with sets. So if we take my set and try to get the first or the element at the 0 index, it won't let us do that. The set object is not subscriptable, so you can't use this slicing syntax with it. In Python, an object is subscriptable if it contains elements that can be accessed by an index. It contains ordered, accessible sub-elements.
So I'm just taking notes of that. Cannot use slicing meaning cannot um, do my set at 0. Not only that, this means sets are subcreatable.
So let's do something silly like number equals 1, and then we do the 0th element of 1, right? We get that same error. The int object is not subscriptable. 1 doesn't contain any subelements. And in a set, it's not subscriptable because it doesn't make any sense to get the first element in sort of a big random pile. However, you can add elements to a set. So let's take my set and then add D. And let's just take a look at my set. There we go. Notice that this is different than the append function in the list, which specifically appends the element to the end of the list. Set uses the add function, which is kind of like tossing the element onto the pile. However, like with lists, you can use the membership operator to return Boolean values. So we say A in my set, it returns true because A is there. We say Z is in my set, we get false. Which is kind of like tossing the element onto the pile. Also, like with lists, you can use the length function. So my set should have 4 elements in it. Perfect. And somewhat confusingly, set does have a pop function. You pop an element off the set. Of course, unlike with lists, you're not going to get an element from the end of the set per se, but it will grab an element for you and return it while removing that element from the set. So we can write something like while length of my set dot pop. And let's make sure we print that out so that we can see the results. And it's just happening to return these in order here, but keep in mind that order is not guaranteed. If you want to remove a specific element, you can do that. So my set dot discard A. Now notice that it didn't throw an error even though my set is empty. It's just an empty set right now. Let's reset this again. And then print out my set. And you can see it only contains the elements B and C. Now tuples. Let's move on to those. So as a quick review, they're very much like lists. They have an order, except they're declared with parentheses. So my tuple is A, B, need commas in there, and C. So while tuples are ordered and subscriptable, the trick here is that you cannot modify them. So we can get tuple, get the first element of the tuple. The order does matter here. But if I try to do my tuple element at the index 0 equals D, we're going to get an error there. Tuple does not support item assignment. And of course, I can't show you any nifty functions for adding, removing, or popping elements off of tuples because you cannot do that. You can't modify a tuple. So, okay, why would we want to use tuples? So, like I mentioned before, the trick here is that you cannot modify them. So we can get tuple, get the first element of the tuple. The order does matter here. But if I try to do my tuple element at the index 0 equals D, we're going to get an error there. Tuple does not support item assignment. And of course, I can't show you any nifty functions for adding, removing, or popping elements off of tuples because you cannot do that. You can't modify a tuple. So, okay, why would we want to use tuples? I can't show you any nifty functions for adding, removing, or popping elements off of tuples because you cannot do that.
Declared with parentheses um, are ordered and subscriptable and cannot be modified. What else do we know about it? Pretty much nothing.
Do that. You can't modify a tuple. So, okay, why would we want to use tuples? So, like I mentioned before, they are more efficient than lists because Python doesn't have to worry about growing or changing them. It can allocate exactly as much space as it needs to in memory to really store these tuples compactly. But let's say you don't care about that. Another benefit is that they're often just kind of used by default. So let's write a Python. And of course, I can't show you any nifty functions for adding, removing, or popping elements off of tuples because you cannot do that. You can't modify a tuple. So, okay, why would we want to use tuples? So, like I mentioned before, they are more efficient than lists because Python doesn't have to worry about growing or changing them. It can allocate exactly as much space as it needs to in memory to really store these tuples compactly. But let's say you don't care about that. Another benefit is that they're often just kind of used by default. So let's write a Python function that returns multiple values separated by commas. As it turns out, you can do this nifty trick in Python. So returns multiple values. Return 1, 2, 3. And what exactly is this function returning when we separate them by commas with this? Let's call it and then put whatever it's returning into the type function. It returns a tuple. Okay, now of course we can also do this, still the same type, but it turns out that Python doesn't really require parentheses around tuples at all. So you could say my tuple is 1, 2, 3, and that's perfectly fine. My tuple. It,
Doesn't require brackets. So parentheses. Which is a very important feature because there are so many different types. Like this is, sorry. This is for list. This is for sets. This is for tuples. So confusing. If it is not required, then perfect. Only two types of brackets. Perfect.
it's a tuple. Although for situations like this, if I saw this in code in the real world, this would look really odd to me. I would ask that the programmer please put parentheses around that. But just so you know, you don't have to. And the really cool thing is that in the case where you're returning multiple values from functions, this syntax without the parentheses is actually preferred. So in this case, we prefer the syntax without the parentheses, but we do prefer that you add parentheses when you're just declaring a random tuple. And back to this function here, if you want to set variables, set many variables in a row, you can do this. So let's say A, B, C is equal to returns multiple values. Print A, print B, print C. And unsurprisingly, we have all these values set. So this is called unpacking values, which we'll see again a little bit later in this chapter. So while tuples are sometimes stubbornly unchangeable, I think you'll find as you continue your Python journey that their convenience and elegance more than compensates in many situations. In my experience, most data structures you work with in Python will be lists, but that's followed very closely by dictionaries. Lists and dictionaries, dictionaries and lists, they work together like duct tape and WD-40. You know, if it's moving and it shouldn't, use duct tape. If it should move and it doesn't, use WD-40. It's a complete solution for every situation. So with the lists and dictionaries combined, you can solve just about any problem with Python. They'll be easily 95% of the data structures you're working with. Let's go to the code. So let's start working with this dictionary of animals I've created. Here I've left a comma at the end of this last key value pair in the dictionary, and this is called a trailing comma. So you don't technically need this. This code will run just fine without it, but it is good practice. It's convention to have it on the end there. So if we do animals A, we get aardvark back. We can add a dog by using a similar syntax. Animals D is equal to dog. Great. And if we print out the dictionary, of course, we can see that's added there. Now let's update the dictionary. Change A to antelope and print out the dictionary. Great, we've made A an antelope instead. If we want to get the keys and values of the dictionary, animals.keys and animals.values, and that just prints out the keys and values. And notice that this is a dict keys object rather than a list. It looks kind of like a list. You can iterate over dict keys. They are immutable. You can't change them directly or just add to them. You have to modify the underlying dictionary in order to change them. But you can convert them to list. So if I take this, pass in that, there we go. We've actually just made a copy of this keys, dict keys object.
Don't go down. I want you to just play the video.
And turn it into a list. Okay, so what if I try to access a key that's not present? Animals E. We get an error. So there is a function that's pretty handy for this, and that's called the get function. Animals.get E, and as a second argument, you can pass it a default. All right, so it didn't find E, it returned elephant instead. You don't have to have a default value there. This will actually, if we print this out, you can see it is a none object that gets returned if you don't provide a default value. And of course, if we do something like this, we'll get antelope back because that does exist. It returned elephant instead. You don't have to have a default value there. This will actually, if we print this out, you can see it is a none object that gets returned if you don't provide a default value. And of course, if we do something like this, we'll get antelope back because that does exist in the dictionary. Like strings and lists, you can use the length function on the dictionary. So length animals, we get 4 because there are 4 keys in our dictionary. Let's look at one really common pattern in programming, and that's a dictionary where the values are lists. So I'm just going to copy this, and let's just keep the first 2, and then turn this into a dictionary of lists. And then we can add our old friend, the antelope here. Okay, great. So if we want to add bison to the structure of animals, that's pretty straightforward. Animals, bison starts with B, and then we just append bison. Okay, great. But what if we want to add cat? The list for C doesn't exist, so we have to do animals. C is equal to, rather than just appending, is equal to a new list containing cat. But what if there was already a caribou in that list and we just overwrote it? What if we don't know whether that key exists or not? We just know what we want to add. So we have to write something like this. If C not in animals, animals C is equal to a new list, and then in either case, C append cat. Great, so that works. And notice that the not in operator tells you if that key exists in the dictionary or not. Is there a solution to this sort of convoluted code? And there is. That is the, as you can probably guess from the title down here, the default dict. So we have to import this from the collections package. From collections, import default dict. Okay, so now we have access to it. To create a new default dict, you need to pass the type of object that it should return by default. So animals equals default dict list. We want to return a list. So common mistake here, a lot of people will return or pass in rather an instance of the thing that they want returned, but you actually have to give it a sort of callable function. Say, use this every time you need to make a new thing that gets returned. So now we have our new default dict. And if we look at it, it doesn't have any values in it yet. So let's make one. Animals E append elephant. And let's take a look at it now. Great. We didn't have to say, hey, this is equal to a new list. It just did all the work for us and automatically added that. If we say, make a new thing that gets returned. So now we have our new default dict. And if we look at it, it doesn't have any values in it yet. So let's make one. Animals E append elephant. And let's take a look at it now. Great. We didn't have to say, hey, this is equal to a new list. It just did all the work for us and automatically added that. If we say animals E append emu, that gets added as well to our new list. And the really cool thing is if we say animals F, we get back an empty list because we haven't added anything there yet. While lists and dictionaries work excellently when combined with each other, the same cannot be said for WD-40 and duct tape. So in that way, I think you'll find Python data structures are far superior. Python has a really neat feature that's somewhat unique in programming languages, and that is the list comprehension. No, the word comprehension here has nothing to do with understanding, but more to do with the word comprehensive, so systematically listing everything out. For example, my list is 1, 2, 3, 4, 5. Let's write a list comprehension with this. 2 times item for item in my list. Isn't that neat? So square brackets surround the list comprehension, and then there's a syntax frame much like the for loop that we saw before. So for item in my list. Of course, item can be any variable name that you want. Just make sure that you use the same variable name over here when you're doing stuff with it. A list comprehension allows you to essentially make a for loop in one line while returning a copy of the list that you're iterating over. It also allows you to filter or call functions on every item or of a list. So let's play around with it. So like I said, the list comprehension can act as a filter. So for example, my list is equal to list range 100. So this is going to give us a list with all the numbers from 0 to 99. Let's make a filtered list. It's equal to item for item in my list if item modulus 10 is equal to 0. Remember, this is the modulus operator. It gives you the remainder after dividing the variable here by the number on the right. So whenever the remainder after dividing item by 10 is equal to 0, this statement is true. So item for item in my list if it's divisible by 10. And let's see what this looks like.
Okay. I feel like um, this can be very handy. So let me take a note of it. So inside comprehension, my list can be whatever I want, right? So range 100. Oh, I have to make a list of it, right? Then once you make a list of those, I can write to open the comprehensive bracket. Then I'm not looking because I wanna vary myself, if that makes sense. Um, let's say I want to take the modulus, right? So for item in my list, if item modulus 100 is equal to 0. Is that what she no. Okay, everything is correct except there will be an item here, or items. No, they say item. Well, that was a blunder. You cannot use the item, set an item there. Okay. And then just call fill, which will print fill, or you can say print fill. Okay. Hmm. Okay. So the way the syntax goes, what you want in fill first condition second condition. Mm, this triggers me.
All of the numbers that are divisible by 10. We could even do something like this. Let's change this to less than 3. That's pretty neat. It gives you all the numbers that end in 0, 1, or 2. And let's just make this a print statement to make it a little easier to read. There, lie flat. List comprehensions are really great for working with strings as well. I want to show you a new string function called split. Split splits a string based on a character or another string that you give it. For instance, my string is equal to my name is Ryan Mitchell. I live in Boston. Okay, myString.split. And this splits it into two sentences based on where the period is. If nothing is passed in, the split function will split on spaces. MyString.split, and there we go, that splits it into words. We might want to get rid of that period though, and maybe just sort of normalize all the text a little bit. So for this, let's make a new function called cleanWord. And this is going to return word.replace period with an empty string and dot lower. So here, the replace function replaces any instances of the first string, in this case a period, with the second string, which is empty. Effectively, this removes all the periods. And then the next function makes the string lowercase. Calling one function after the other in a single line like this is called chaining functions. It can be handy sometimes to keep your code clean, but be careful not to go too crazy with it, or it can lead to long and unreadable lines of code. So let's use this now in a list comprehension. Clean word, word, for word in myString.split. So now we have this nice clean list of all the words in the text. Let's say that we want to clean and filter at the same time. For instance, only getting the small words in the text. We could do something like this. If length of my string if the length of clean word is less than, let's say, 3. So that gets all the 1 and 2 letter words in the text. So you can see how powerful list comprehensions are. I use them all the time for cleaning text and processing large amounts of data. And as one final example, before I officially dub you the list comprehension expert, the nested list comprehension. So let's just give a quick example of that. Clean word, for word in sentence.split, for sentence in myString.split on the period. So don't get too overwhelmed by this. All this is doing is splitting this original text into sentences and then performing sort of an inner list comprehension on each sentence. So now we have a list of lists, sort of like a two-dimensional structure that groups these clean words by the sentence that they appeared in. So have fun with these. Using list comprehensions is a great way to write clean, readable, and, as Python programmers say, Pythonic code. Dictionary comprehensions are used to generate dictionaries from iterable structures. Just like list comprehensions create a new list, a dictionary comprehension creates a new dictionary. I'll show you
Okay, hold on. Let me.
structures. Just like list comprehensions.
Uh, okay.
Comprehensions create a new list. A dictionary comprehension creates a new dictionary. I'll show you a basic example. So here we have a list of tuples that we'll be using as our key value pairs. Remember, tuples work just like lists, except that you can't alter the value of tuples once they've been declared. And we can create a dictionary from this list of tuples like this. Animals equals item 0, colon, item 1, for item in animal list. And there we see our dictionary. There's this familiar for item in list statement, exactly the same in both list and dictionary comprehensions. But now we need to define both the key and the value separated by a colon instead of just a single value like we did for the list comprehension. And of course, this dictionary comprehension is surrounded with the curly braces, just like the list comprehension was surrounded by the square brackets. Now there's a more elegant way to write this dictionary comprehension as well. Let's check that out. So we can actually say key is equal to value for key comma value in animal list. So what kind of sorcery is happening here? Well, whatever is between the for and the in this statement is what each tuple of animal list is getting assigned to. So remember when we saw earlier when we were discussing tuples and sets, Python allows you to unpack values into multiple variables as long as the number of variables you're assigning the values to matches the elements in this data structure. So we have two items in each tuple here, and we're unpacking them into two key value variables here that we can use. And this just makes it a little bit cleaner. So we can do something like this, but if we try to unpack it into other item, you can see we'd get not enough values to unpack, expected 3, but actually got 2 when we iterated through this list. So that's the dictionary comprehension. Pretty straightforward. Well, what if we want to take our animal dictionary and turn it back into a list? Let's look at the dictionary function called items. Remember we have animals.keys and animals.values. There's actually animals.items. And items returns a dict items object containing a list of key value pairs. So we can turn it back into something that looks like this animal list that we started with just by doing list animals.items. And there you go. But let's say we wanted to get a little more creative. We want each item in our list to have a structure different than the one we started with. Well, we could write a list comprehension. And let's make it key value, or let's call this name value for key comma value in animals.items. This returns a list of dictionary objects with the original keys and values under the letter and name fields in each dictionary in the list. So you can see how powerful both dictionary and list comprehensions are for processing and formatting data in Python.
Okay, so now we are reaching a point where the information, like the last dictionary comprehension, the end of it, went over my head. So here's what we're gonna do. I'm gonna play some music, listen to it for 5-10 minutes, and then we'll come back to this. Um, yeah, that sounds good to me. Let's do that.
They call me Lil C's cause I'm always hot and ready. I'm something like a chief, my title should be El Jefe. And I will never cease, believe until my end day. Your mind give me wop, I ain't talking about Fede. I know you ain't talking to me. I'm loaded, I'm keeping close to my peace. And that's the only time I keep peace. I'm known inside these streets in the LSSA. Chop, chop, time I got come sparingly. Bought a new spot and I live for prosperity. I'm always with the squad, gang, gang, till they bury me. You not with the guys, then it's bang, bang for your heresy. I'm looking dapper with the cut. Got your shorty on my line, like I'm fishing felt the tug. Get demoted to the side, cause your dollar's not enough. Yeah, she heard that money talks, and it's talking about us, so. Your slogans eat a burger, well I don't do the murder. I got shooters that'll do it if I wish like Timmy Turner. Let's take it even further. Any woman that I deem as my queen can make you my worker. That's why I'm buzzing, call that poetic justice. I pull up to your function, turn into a dysfunction. I'm all about my business like an LLC. Fuck it with LC, you'll take an L. See? They call me Lil C's cause I'm always hot and ready. I'm something like a chief, my title should be El Jefe. And I will never cease, believe until my end day. Your mind give me wop, I ain't talking about Fede. I know you ain't talking to me. I'm loaded, I'm keeping close to my peace. And that's the only time I keep peace. I'm known inside these streets in the LSSA. You know the vibes, I keep my spirits high, so I'm likely to raise the bar. It's my time and I never whine. Besides, I'm riding dirty, driving Big Bertha. And if looks could kill my drip, probably commit murder. That's a body. I'm trying to whip an Audi, going Wu Chain crazy like they be calling me Rami. And nobody can stop me unless it stop drop roll. Cause when I'm in the building, it burns. Call that a hot show. I'm laughing like ha 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 ha. Why should I stop? These thoughts are like John. And my drops always raw. I'm not gonna fall off. To the top, I'm a pop. Boom shaka like God. Tired of sucking my cockiness. I'm probably sure they could come swallow this. These rappers be dragging. I'm repping the dragon. Spit fire. We breaking thermometers. The struggle will keep you in chains. I had to change. Pay me a paper, no change. And when you cut the check, what's my name? Well, they call me Lil C's cause I'm always hot and ready. I'm something like a chief, my title should be El Jefe. And I will never cease, believe until my end day. Your mind give me wop, I ain't talking about Fede. Comprende?
You ain't never gonna follow me. Just so you know, just so you know.
They call me Lil C's cause I'm always hot and ready. I'm something like a chief, my title should be El Jefe. And I will never cease, believe until my end day. Your mind give me wop, I ain't talking about Fede. Comprende? I know you ain't talking to me. You comprende? I'm loaded, I'm keeping close to my peace. You comprende? And that's the only time I keep peace. I'm known inside these streets in the LS, SA. Chop, chop, time I got come sparingly. Bought a new spot and I live for prosperity. I'm always with the squad, gang, gang, till they bury me. You not with the gods, then it's bang, bang for your heresy. I'm looking dapper with the cut. Got your shorty on my line like I'm fishing, felt the tug. Get demoted to the side, cause your dollar's not enough. Yes, you heard that money talks, and it's talking about us. So, your slogans eat a burger. Well, I don't do the murder. I got shooters that'll do it if I wish like Timmy Turner. Let's take it even further. Any woman that I deem as my queen can make you my worker. That's why I'm buzzing, call that poetic justice. I pull up to your function, turn into a dysfunction. I'm all about my business like an LLC. Fuck it with LC, you'll take an L. See? They call me Lil C's cause I'm always hot and ready. I'm something like a chief, my title should be El Jefe. And I will never cease, believe until my end day. Your mind give me wop, I ain't talking about Fede. I know you ain't talking to me. You comprende? I'm loaded, I'm keeping close to my peace. You comprende? And that's the only time I keep peace. I'm known inside these streets in the LS, SA. You know the vibes, I keep my spirits high, so I'm likely to raise the bar. It's my time and I never whine. Besides, I'm riding dirty, driving Big Bertha. And if looks could kill my trip, probably commit murder. That's a body, I'm trying to whip a naughty. Going with Wu Chain crazy like they be calling me Rami. And nobody can stop me unless it stop, drop, roll. Cause when I'm in the building it burns, call that a hot flow. I'm laughing like ha, 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 ha. Why should I stop? These thoughts are like John. And my drops always raw, I'm not gonna fall off. To the top, I'm a pop, boom shaka like God. Tired of sucking my cockiness. I'm probably sure they could come swallow this. These rappers be dragging, I'm repping the dragon. Spit fire, we breaking thermometers. The struggle will keep you in chains. I had to change. Pay me a paper, no change. And when you cut the check, what's my name? Well, they call me Lil C's cause I'm always hot and ready. I'm something like a chief. My title should be El Jefe. And I will never cease, believe until my end day. Your mind give me wop, I ain't talking about Fede. Comprende?
I guess that you can say we complicated. We don't like the labels, but we fucking. Got no expectation of you riding, but you can never have no one else to not to get.
They can fuck with my clique, we running this shit. Boy, this is big whoa, boy, this is big whoa. Let me tell them right quick, they can't do it like this. We making them moves, other labels might quit. All we do is write hits, hit them with that 1-2. Haters all on our dick, cause they wanna ride it. When they heard us big, look true facts I ain't gonna say. Call me Lil C's, but I do big things. 2 masquerades, a mass and plays, masking a massive rage I take out on these lames. Artists flip flop, now they're taking defeat. It's a shame they went chasing the cheese rat race, but it seems Wu Chang stay with the heat. Now they're soon to be vagrants in need. See, I'm great in the sheets. No pad better, don't matter, cause you'll get fucked up for all that dumb chatter. Send shots, grrr-ta-ta-ta, run scatter, running rings when we plan it. I ain't talking about Saturn. Shouts out to Vinny Pistone, 100K investment, not getting pissed on, but you're getting pissed on if you ever mention me or my squad. C's heading to the top, since y'all giving that sloppy. Let the speakers knock a hit unconscious quick if you're talking slick, cause I'm strong when the ganja hits. See, I'm a lot, the king of the parking lot in this. Well, y'all just cop out, call that a crock of shit. And I ain't even the type to say names. If I said it, I meant it, yeah, I don't play games. And if I meant it, I did it, I go and take aim. At your brain, at your face, shoot your mainframe. Like, I ain't gotta say much just for them to give it up, cause I'm putting it down. Black rose on my cup, yeah, we living it up. Got my head in the clouds. If they wanna mention us, big crew turning up, tell me how does that sound? Now I'm asking, but how? What now? Well, I gotta tell ya, they can fuck with my clique. We running this shit, boy. This is big whoa, boy. This is big whoa. Let me tell them right quick, they can't do it like this. We making them move, we making them move. Other labels might quit, all we do is write hits. Hit them with that 1-2. Damn, haters all on our dick. They wanna ride it when they heard us big. Boy, this boy, big whoa. Boy, this boy, big whoa. Boy, this boy, big whoa.
Bow down that queen cobra, I ride. Gross test is a few, I'm ready tied. If you gotta mess your hip, you gotta hide. It'll be one to fuck these beats to real tight. It's nerf on a dick suck on my clit. When your man is resting his on my left it. Got a bunch of exes, I don't left it. I was acting too brave, well, I'ma just spend it. Seeds, tobacco seeds, smoking ganja with my G's. Italian, roots are Chinese. You a billionaire, I'll get down on my knees. Put it down my throat, coming to go. Get past me, left the best show. Bling on my body, got me acting cutty. God loves me, that's why I got a fatty. Bang bang shots in the arcade block. Yellow gun down, your time's out. Tick tock, mad at me for your mistakes. Shut up, don't flop. You are broke bitch while I stay on the top. Oh, are you offended? That's your service that no one attended. Yeah, all those people pretended. Call me PDM, your career I ended.
Boy, this boy, big whoa. Boy, this boy, big whoa. Boy, this is big whoa. Boy, this is big whoa. Big whoa.
Heaven sakes, I've never felt the same, yeah. You broke my heart, now I can't forget the day, yeah. Gray fog, gray clouds of astray, yeah. She holds us in, now I can't look away, cause Christ sakes, they done me up, I'll never be the same. Don't believe what they say time heals, but I don't feel the same. Got acid in my veins every time I see your face. This is the day you got me falling apart, put the blame, I put it all on you. Saw your lips on his in the back of your car. When we crossed our hearts, we stayed true. And they say you'll never learn until you crash and burn. So look me eye to eye and tell me, won't you tell me why? You told me up and I'll never be alright. Yeah, I'll never be alright. I'll never be alright. They say your first love never dies, even after all this time. Fucking first love, try to kill it like 100 times. Can't forget your face, guess I'll wait another lifetime. Broken on my knees, won't you please go a lifeline? But I saw you with your new boy the other day. Watched you hold his hand, I couldn't look away. I thought we were forever, but you don't feel the same.
Thank
Got
God, acid in my face all the time. On you, keep going, all the day true. Say you'll never learn until you crash and burn. I tell me what you tell me why. You'll never be alright. And never be alright. Be alright. Love that song. You know what? Let's hear it one more time and then we'll jump back into it. Felt the same, yeah. Everything, the same thing, never had the same, yeah. Can't forget the way, yeah. Take us in this game, yeah. The songs I can't break away from. To me for this. Cause believe what they say, try here, but you don't want to say. Like a message in my face every time I see your face. On you, on you. so hard to say true. They say you'll never learn until you crash and burn. So tell me why, but be alright. Alright, let's get back into it.
This challenge is so much fun, we literally can't do it without a smiley face. What we're going to do is take this smiley face ASCII art and encode it into a list of tuples. Each tuple will have a character, followed by a number, how many times that character appears in a row. For example, the string AA, AAA, BBBB, AAA will be encoded as A5, so A for 5 times, B4, B4 times, and A3, A3 times. In computer science, this is run length encoding, where you run along a string and record the character and the count as you go. It's really useful for compressing data that doesn't have a lot of variation in it or maybe has long stretches of the same character over and over again. So in this challenge, you're going to write two functions. One is encode string, where you take in the string and encode it into this list of tuples. So you're going to return this list of tuples. And the other is decode string. So it takes in that list of tuples and returns the original string. As usual, there's the hints file if you need any ideas. All right, so go do your encoding, do your decoding, and most importantly, do your coding.
Okay. So I have some idea of how I want to do it, but let's see. Let me write write my ideas. Let me do that first. There is the mirror. So, should I put it in this file only? Let's just do it again for F. So, okay. Here's my idea, right? If what's the sign that's used in every modulus, right? So, modulus is the sign used in this. We can say string, multi-line string. Okay? If this, let's say this is the test case, right? And we know that when you try to write it out, there will be a new line here. So what we can do is split the string based on new line and save it on a new string variable called let's call it linewise for the lack of better term. So linewise will just contain this part. But what I do know is the length of line wise. Okay, so what I can say is that run a for loop that's less than the length of line wise, right? Pick up the first character in line wise called line, but whatever is there, or how many ever is there, and depending on how many times the loop runs, create a tuple. And once you get the tuple, right, that's the final outcome, right? Get a tuple, a list of tuples. Once you make a tuple out of it, dot append on result, right? So that's simple enough. Yeah. So let's put our coding hats on and try to code it. Okay. There. The first thing is you create something called a result that will be an empty list. Then you create something called line wise. Now that won't be an empty string. Uh, that will be whatever string value is. The split. Is there a lag? Interesting. Dot split at new line. Is it not backspace? Is it this space? Wait, what? This is how you write new line, right? Yeah. Oh, I see. This has to be inside this. Double quotation. I hope this will work. Not sure. Once I get this, I open a for loop. Now line-wise is a string. Yeah. No, sorry, not a string, a array of strings or a list of strings in this case. So for line-wise, I believe I can do this. Till it's not empty. Why is it saying error? In. So do I have to use? Hmm. That's very, very interesting. I have to use this. I cannot split line-wise up. I want to see line-wise in the debugger. Why? Because I don't know why I cannot. I want to know why I cannot just do that. Okay. Anyways, for now, let's, for the sake of solving this problem, line-wise should read this, but that's no longer line-wise there. This should be num. And let's make num equals to, yeah, this is not very Python. This is pretty much I'm writing code in Java. This is how you do it in Java. But okay, once you get num, you get the len, run the entire range. Then what does line-wise has the entire thing, right? So let's read in a line equals to line wise at num. Num is not a right name. And there's also a way so that I can change all num to I, but I just don't know what it is. I equals to 0. Okay. Then there's that line wise. Once you get that line, how many values are there in a line? Well, then I have to create a tuple. Give me one sec. Hold on, guys. I'll be I'm so sorry, guys. Something came up that I had to go. Okay, where was I? I haven't forgot my train of thoughts. How long have we been live for? Around 4 hours. You know what, guys? Let's give it a rest here. I will be back in some time and we will continue. Let me play that song again.
They call me Lil C's cause I'm always out in Red Dead. I'm
Take care,
something like a
guys.
chief.